Thank you. You
Hey, good morning, everybody. Thanks for joining us. Before we get started, just want to quickly welcome you. My name is Len Thompson, and I'm CA's Mainframe Community Manager. Before we get started, again, just quickly, if you are in this via the audio broadcast, which it looks like almost all of you are, please use the Q&A box in the WebEx to ask any questions you might have. Please use the Q&A box, not the chat box. But feel free to use it throughout the session, and then we will answer any questions that there are at the end of the session as we have time. And that's it. So I'm going to hand you off to Dick now. So take it away, Dick.
Good day, everybody. We're continuing with our CA IDMS Database Maintenance series. If you'll excuse me for a moment here as I reposition to our starting point for today from where we left off last Friday. Okay, so what we were talking about last week, we had moved into the portion of the presentation that talks about the expansion or enlargement of the databases, and we had talked about the short-term options with the expand page or the extend space, and then we had moved on into the more long-term options or utilities that provide a much more efficient database at the end of the process. We talked about the unload and reload utility, which has always been the standard for enlarging these databases. But where we want to start today is with the REORG utility. REORG utility is relatively new. I'd say it came in somewhere around release 16, 17, within that time frame. And as we point out here on the first bullet, the REORG was created with the same general processes as unload, reload. So it goes through and it's going to take the data off the database, write it to intermediate files, and then it's going to take those intermediate files and use that data to then reload the database. So it's very much the same general processes that we saw in the unload, reload. However, the difference with reload or with REORG is that we are going to use concurrently executing jobs to process different portions or what we term as slices of the database. So instead of having one job out there processing the entire database, you can have several jobs that are just dealing with individual portions of the database, and they're going to be running at the same time. So as this last bullet points out, the design goal is to reduce the start to finished elapsed time. So if you, let's say we're running an unload reload and it maybe would take about 3 hours to complete, you may go through and create a REORG job and indicate that you want to break the database up into 3 slices, and those jobs would accomplish the same process of unloading and reloading the database in about an hour. So we've found through various testing that it's pretty close to the fact of if I run it, with 4 slices, it takes about a quarter of the time. So it can reduce the amount of time or potential outages that you have on these databases to perform this process. The thing is that it does take more resources. So you are going to need more disk space in many cases, and it does require more CPU overall within the structure. But again, the goal is to reduce the elapsed time that it takes to do the unloading and reloading of that database. So let's move on to this next slide. And if you recall, we were looking, we saw similar type slides where we kind of talked about the various utilities as we go on. And this slide we've modified to a little bit. We don't go into a lot of the detail because there are so many different files that are involved here and so many different jobs that I really want to use this particular slide to more or less talk about the utility conceptually as opposed to the inputs and the outputs. Let me just say that the input for the individual reorg jobs still does come out from the SYS, or goes into through the sys-ipt file, and all of the jobs will create an output listing through syslist. But what we have here, you're going to end up submitting a single job to start the reorg process. That initial job, sometimes referred to as the main job, its responsibility is to go through and analyze the full syntax specifying how you want to unload, reload this database. And what it will do, one of the things that you'll specify is how many slices you're going to execute or process within this particular job. So in this case, let's say that we've come through and we've said 4 slices. There's slices is 4. So what the reorg is going to do is basically break the database up into 4 pieces. And then once it does that, now the reorg main job will then submit any number of jobs that will be run concurrently. So it automatically submits through the internal reader these individual jobs. So for reorg to really be able to perform its magic, what you've got to do is have enough initiators available to support all of those jobs. So if you're going to have a 4-way slice, you're going to want to make sure that you've at least got 4 initiators that are going to be there and available and dedicated to the reorg jobs. If you don't have those initiators and only one of the jobs can run at a time, you're basically single-threading everything, and it probably is going to take longer to do the reorg. So make sure that you've got enough initiators. So reorg is going to go through, and let's say there's 3 areas that are being processed within this reorg. In one slice, it will take, if I do a 4-way slice, it'll take about 1/4 of area 1, 1/4 of area 2, and 1/4 of area 3, and say that's in slice 1. And then continue on through all of those areas. So these individual jobs will then go out and concurrently read the input database and write all of the information out to the intermediate files assigned to those jobs. Then reorg, when it gets into the reload phase or tasks, it then has these 4 jobs that end up writing into the new database, the new copy of the database, on a concurrent level. So what we're really trying to show here is that reorg job in a 4-way slice, you're probably going to have 4 concurrent jobs processing. You actually may have a few more, because based on the characteristics of the database, reorg may submit an extra 1 or 2 reorg jobs to perform some other processes or some of the tasks that can be done concurrently while some of the other tasks are processing. Now, all of this processing is controlled through a control file. The main job that you submit is going to go through and build this control file, and it's going to contain the information about the areas that are going to be processed, any dependencies of sets that point into the areas being unloaded. It has the information about the different data sets that are going to be required and how each of those data sets will be allocated to specific jobs. So once it goes through and it builds this startup file, the main job then goes through and submits these multiple concurrent jobs, and they all start processing. They go to the control file and they look for tasks to be executed. For example, the main job, well actually the main job at that point in time, once it's ready to start the unload, it becomes just another job just like all of the other slice jobs or concurrent jobs. So it's going to go through and say, well, here's a task that says unload slice 1, so it starts processing it. Another concurrent job or one of the concurrent jobs comes through, looks at the control file and says, oh, well, this unload of slice 1 is being processed by another job already. There's an unload for slice 2. I'll take that and I'll start processing that particular task. So all of these concurrent jobs look at the control file, and then when they complete a slice, they go back to the control file and indicate that that particular task has been completed, and if there's another outstanding task to be executed, they then go through, allocate that task to themselves, and begin the individual processing. So all of this structure is maintained through the control file. So some of the points, I mentioned a couple of these, but again, the initial job is submitted by you just like any other typical job, and then that job submits through the internal reader all of the concurrent jobs that are going to be required for the reorg operation. There are a lot of data sets that are going to be required for these different jobs, for the different characteristics or type of processes that they perform. So what we provide is a model statement for JCL, and we're going to be looking at that in a little bit and discussing that to a bit. But to make your life easier, you can supply this model, and IDMS or REORG through that structure will then allocate the data sets based on the model that you give it. Again, we'll talk about that as we come up. The various jobs are coordinated through the control file, as I mentioned. I should point out that there is an in-queue logic. So if one of the jobs is going to go out and look at the control file, it in-queues on that data set, so none of the other jobs can look at it until it finishes its work. It says, here's something for me to do. It updates the control file, releases the in-queue, and then another of the jobs can come through and do whatever is necessary against that control file. There are a number of restart points within REORG. So if something happens where one of the jobs fails for some reason, the control file will have that information in it, and a subsequent task may come through and find out that a task failed, and then it will try and restart that task. There are some conditions that just may not be restartable. For example, if you've got files, intermediate files that are just too small, it may restart that task, process it, and then get another B37, and eventually it will come through and say you've reached a limit. But we do try and do restart logic in there to make this thing as easy to execute as possible. And then finally, there are reports on the control file that are available to you. And these reports are generated by each of the standard jobs when they terminate. So they give you the status of the control file when that particular job finishes. You also have the ability to submit a job and request that this status report is being executed. And often, if you do have some type of a problem with REORG, one of the things that will be requested is that control file report at the end of the process. So if you're going to open a case for REORG, you might want to make sure that you've run the control file report and have that available for level 1 to review or pass on to level 2. So within that report, what it's going to give us is the status of the various tasks, what's been completed, what's still pending, etc. And the work files, all of the work files that are in there, indicating which file has been allocated to which job processed each one of the tasks. So a lot of really good information that can be used by various individuals on some type of problem solving. Okay. So REORG, the thing to point out here is everything that unload reload could do or can do against a database can be accomplished by REORG. But they also took the opportunity to make some additional improvements to REORG. So there's a couple other things that can be done within this structure. And that really gets into some of the index processing specifically. So where unload reload, you couldn't change any of the characteristics of indexes themselves in terms of different types of keys or things like that. But you actually in REORG can change sort keys, you can change the sort ordering, and you can change a set from a non-sorted index to a sorted index, or from sorted to a non-sorted index. So we do allow within the structure of REORG some modifications to the index structure. For example, where we say change sort keys, if there is another field in the record, in an existing record, that you want to include as a sort key for that index, you can redefine the index so that it brings in that extra field. So that's something you couldn't do with unload reload. And then, though there might be some of you out there that are familiar with a product called Easy REORG. There's a product that was created by a company called Pagito, and it's used for allowing large unload reload type operations to be able to be run in a background while you're still updating the old copy of a database. And what we've done is, or what that utility or that product required, was a file of DB keys, so that it could make the comparison or the coordination between the old DB keys and the new DB keys of the database. And we do also create within REORG that file. So REORG is compatible with this Easy REORG product that some of you probably have familiar and have used in the past. One of the other things that REORG will do, you can optionally lock areas at the start of an unload to prevent inadvertent updates. So those areas stay locked through the course of the REORG operation. So you don't have to be afraid that somebody may go in and maybe run something locally against those databases. So that is another option that unload reload did not have available to it. Now, as I pointed out, REORG will use a large number of work files. And the more slices you create, the more files that you're going to require. Think about if we just had unload reload. We're taking all of our data and we're writing it to one massive file that gets passed down to the reload steps. Well, now I'm going to have a slice, or one of these jobs is going to process a slice, and we're only going to use, or in a four-way slice, maybe only process a quarter of that database. But while we're going through that processing, we may find a record that we say, during the reload, it's going to have to go to a different slice. So we're going to have to write that record to a different file than all of the other data that would stay in slice number one. So each one of these jobs has got to have data sets for all of the slices. So again, as you increase that, you're increasing the number almost exponentially in terms of the number of files. The files are not as big, but you still have a lot more data sets. Now, these data sets, REORG will dynamically create the files and delete them at the end of the run. That is, if none of the data sets are allocated, REORG will allocate them and then free them. If REORG starts running and says, I want to allocate this data set name, and it finds that data set name in the system already, it does not allocate the file. It uses that file that already exists, and then at the end of REORG, it will not delete that particular file because it says, I didn't create it, I'm not going to delete it. So the main thing here that I want to point out is as you're running REORG, you probably want to make sure that none of these intermediate data sets exist in your system if you want REORG to be able to handle all of the dynamic allocation and deleting of these particular files. Now, the data set, all these data sets have got to have characteristics, space characteristics, data set names, etc. So what was created along with the REORG utility was another utility statement. And I should point out REORG is a utility statement. It runs under the control of IDMS BCF. So another utility statement that was created was the create DS module, dentures are slipping, create DS model statement. And this is going to allow you to specify the characteristics of the file. So we're going to take a look at an example of the create DS model. I know we are not spending time going through a lot of syntax in this class. We're just talking about the usage of the utilities, but I think it's important to get an idea of what you can specify within this particular structure. So each utility that would be able to dynamically allocate data sets, which at this point in time it's still only REORG, is going to come through and have some general DDNAME characteristic. And REORG always creates all of its intermediate files starting with the character of W. And then the second character is going to indicate a particular type of file. For example, a WI would be a file that deals with indexes. WS might be a file that deals with something to do with sorting. WU is just a general user data file. So the first thing on the create dataset model is you specify the DD name, the general DD name that you're going to be using. And what you're going to be doing there is using wildcard matching. So what we have here is create data DS model W asterisk. So that says for all of anything that starts with a W, use this particular characteristic. I have seen many sites, once they've started using REORG and they feel comfortable, some will have a create DS model statement for WI asterisk, another one for WS asterisk, and they'll get down and they'll code model statements for the different types of files that REORG is going to use. The next parameter, marked here as substitution parameter, this is going to indicate the high-level qualifiers for the data set name for each one of the files that will be created using this DS model. So using this model, every data set that is allocated is going to start with dbdc.dbcr.wrk dot, and then the asterisk dd specifies the DD name. So it would be .WU0001, WU0002, WI0001. So the substitution parameter basically takes the DD name and puts that in as part of the data set name. Storage class, these are, where do you want these data sets allocated? You can specify anything that would be on a JCL DD statement. You can specify volumes, the units, things of that nature. And then we're going to have an indication of the amount of space that you want to use and also the block size for the files. Now, one of the things that I want to mention here, this can seem a little bit daunting at times. What do I put in there, especially if you're using REORG for the first time? There is an option within REORG that you can run REORG with an estimate parameter. And what that basically does is it performs the unload, but it doesn't write any of the data. But it keeps track of the amount of data that it would write to each of these individual files. And then at the completion of that estimate unload, it goes into the control file and updates each of the different file entries within the control file with the amount of space required by that file. So when you then do the real reorg, and in that case you would probably just want to say reorg semicolon and use the characteristics in the catalog, we will go through and allocate the amount of space that the estimate run determined was necessary for that particular file. You still would have to create a DS model statement so that you would give the data set name, where you want it to be allocated, but you don't have to worry about the block size and the space allocations. If you should run that real execution of the reorg and you do put space and block size in there, what you put in there will override what the estimate determined was necessary. So you want to make sure that if you're going to use the estimate method, that you don't specify the space or block size within that DS model. But again, this is a utility statement that's run along with the reorg that's trying to make your life easier for all these, allocating all of these data sets. All right, so let's talk about the steps to run reorg. And within this structure, we're going to talk about a couple different options, and it really depends, these options depend on how you want to create the environment for the reorg. So the first thing is we start up with a lot of these things we're going to be familiar with from the other utilities that we ran. And first, if the physical characteristics of an area are to change, the following steps should be done prior to the actual reorg. Now, where we're saying the physical characteristics are to change, something like this would be increasing the number of pages in an area, or the page size for an area. Ostensibly, you're probably going through and doing this reorg because you want to expand the database. So if you're making those types of changes, you want to do this first step of allocating the information, these files first. So you want to create a new reload statement or new reload segment with the new page size, page range, maximum record per page, whatever you're changing. From using that segment, you'll want to create a new DMCL and then link that into a load library. I strongly recommend that you use a different name for this new DMCL. You want to allocate any of the new data sets with their appropriate characteristics, space, and then block sizes, things of that nature. And it's not a bad idea. I mean, if this is what you're doing, you can certainly also do a format of those data sets at this point in time. That would certainly be permissible. You then want to make the areas involved unavailable to any copy of IDMS in an update mode. So if these areas are allocated to a CV and that CV is going to stay up, you want to make sure that those areas involved are varied to minimally retrieval mode so that nobody can be updating them while you're trying to unload them. Of course, strongly recommend that you back up all these areas in case you have some type of a problem and you need to go back for some type of recovery operation. And reorg, as with unload reload, does not allow logically deleted records. So if there are logically deleted records, you'll want to run the cleanup utility to get rid of those LDELs. Remember, we mentioned that you can run the print space report to get a quick report identifying whether any logically deleted records exist within the areas that you're going to process. Okay, so we're going to start looking at some of the options now. This first one, if the target database files are the same as the source, we'll want to do the following steps. Now, one of the reasons I might have this situation is I might not want to change the database. I might just have a lot of overflow conditions, a lot of indexes are inefficient at this point, so I just want to reorganize the existing database in the files that were there. So basically, I'm going to use the same data sets for the unload or for the reload as were used for the original database. So in this particular scenario, first thing we'll execute, and we'll specify a command called stop after unload. This tells REORG to start the processing of the unload, but when all of the tasks that are required to unload the database are completed, REORG will stop. So all of the concurrent jobs will terminate, the main job will terminate, and it's just basically the end of the unload process. If you did not specify a share option and areas were locked, you may want to go through and do an unlock against the target areas, the areas that are going to have data stored back into them or updated because of cross-area pointers. You want to run the format utility against the areas into which data will be reloaded. In other words, if I've got a database made up of 3 areas, A, B, and C, and A and C have pointers into B, and it's B that I want to perform the unload against, and unload reload, because that's the one I'm going to reorganize. What I want to format would be area B. I do not want to format area A and C because its data was not unloaded. Only information that would be required to connect these cross-area sets, but they will be updated with that new DB key information. So you would, in that scenario, you would only format record or area B. So that's what we're saying, with only those areas into which data will be reloaded. You'll execute REORG specifying stop after cleanup. So once again, you start another job, and you would basically say REORG stop after cleanup, submit. This new main job comes along, recognizes the fact that the next tasks to be executed are reload tasks. It will start the reload process and submit concurrent jobs to go along and concurrently process that information. And then when all of the reloading is finished, it'll go into a cleanup stage where it deletes data sets and does some final work, and then it will clean up or terminate, and all the jobs will be finished. Finally, again, back up all the areas involved with the REORG so that if you have to do a recovery subsequent to the completion of the reload, you can always restore that database and not have to redo the REORG as part of your recovery. And then validate the reloaded database, as we talked about last week, running some of your programs, maybe running DBAN, running print space to verify numbers, things of this nature. Now, if the target database areas are different from the source and they use different DD names, the DD names would have been specified within the segment, and that would be your decision to not use the same DD names. So if that is the case, you would run the format utility against the new target files, execute REORG specifying stop after cleanup. Now, the reason we don't have to stop after unload is that the new DMCL will point to the new DD names, and so at the completion of the unload, REORG can continue processing through the reload and just uses the new DD names, which you've already formatted, if we've already formatted those files, and continue right on with the reload. So you don't have to have that manual step of redoing or resubmitting a REORG job to start the reload process. So again, it runs to cleanup. After everything is terminated, you then again want to back up the database after the REORG process completes and validate the reloaded database. And then our last option here is if the target database files are different than the source, but they use the same DD names. You might want to do that because you don't want to do an extra step at the end of maybe bringing the DD names up to the current DD names, or you don't want to change your CVs to deal with the new DD names, however you want to implement this structure. So if the DD names are the same as the input DD names, then you're going to have to do a few more steps. Again, you can run the format utility against the target files, against the new database areas and files. You'll run REORG specifying stop after unload, ensuring that REORG JCL and the JCL in the concurrent jobs that get submitted point to the same, all to the input source files. You'll then go through and execute REORG specifying stop after cleanup and submit. So that now starts the reload process, but you want to make sure that the main job that you submit and the JCL that gets submitted for the concurrent jobs now point to the target files. You back up the areas involved at the completion of the REORG, and you validate the reloaded database. Now, one thing I want to point out here, notice that says a reference to the JCL in the REORG JCL file. These concurrent jobs that are submitted, you do have to specify or define JCL for those. They're typically going to be basically the same JCL that you would use for the main job, but the input parameter would just say REORG. And you're going to put those into a PDS, put that JCL into a PDS, and specify that PDS on the main job through a DD name called RORG JCL. And that is where the main job will go out and look for this JCL and submit that information and execute it. Okay, now another utility that I mentioned earlier in this section on enlarging the database was the convert page utility. And convert page it's actually a very rarely run utility, to be quite honest, but it does provide a functionality that may be important to you at some point in time. We talked about extend space, and we said that you could extend the space of an area as long as there are pages available at the end of the area that's going to be processed. So let's take the example where I've got one area, and it is in my database, and the page range for that area is 1001 through 2000. And we'll call that area A. And area B has a page range of 2001 through 3000. And area C has a page range of 3001 through 4000. Now, area B ran out of space in the middle of the night. So you really don't feel that you've got time to do an unload reload or to do a reorg, so you decide you want to do an extend space. Well, area C, well, area B, if we're going to expand it, it's got to start using pages 3001 through how many ever pages I want to add to that area. But area C is using pages 3001 and higher. So I don't have room to do the extend space. So what I can do is run the convert page utility against either area B or area C to move those to a different page range that is available within my CV environment. So let's say that I've decided I want to move area B to page 4001 through 5,000, because 5,001 through 6,000 are available. Nobody's using those. Well, certainly I could do an unload reload, but that kind of defeats the point where I don't have time. But what I could do is run the convert page utility. Convert page is a utility statement that runs under the control of IDMS BCF. The input parameters come in through syslist, and syslist is where we produce an output report. And what we're going to do is take the original database and read a page from that original database. Let's say in our example for Area B, it started on page 2001. I'm going to take 2001 and I'm going to change that page to 4001. And all of the DB keys that reside within that area that use that old page range will be modified to use the new page range. And then the other areas that are involved, if they have pointers into that area, their pointers will also be updated to reflect the new DB key structure. So this does not allow me to increase the number of pages. It does not allow me to increase the page size. All it allows me to do is to change the page numbers in which this area resides. So if I have a very full area when I start, when I finish the convert page, I'm going to have a very full area when I finish. If I have overflow conditions, that hasn't changed. All that changed is the page numbers. But what this has done for me is then allows me to do an extend space on B using that new page range and the subsequent pages that are available at the end of B's original page range. So I can then go through it and do the extend space. So this, again, all it's doing is converting the page numbers for an area. So again, use the convert page utility to change the page ranges of existing areas to consolidate free pages. If you need to add pages to an existing page range using unload, reload, or extend space procedures. Okay. So again, it's kind of a preparatory step to doing any of those other three processes within the structure. You must define one or more new segments and include them in a DMCL or alter the definition of an existing segment and include it in a new DMCL. The old DMCL is going to be specified through the sys-IDMS statement, and part of the parameters for a convert page will specify the new DMCL. So you want to create this new DMCL with a different name. You must remember that you're going to convert all the areas touched by any cross-area sets or linked constraints because you're changing the page number, which changes DB keys, and DB keys are part of the pointers that would cross into those particular areas. Things that you cannot do, as I mentioned, you cannot change the number of pages assigned to an area or the page size of that area. It is just a simple copy it over, changing page numbers. And convert page must run in a local mode, and update activity must be quiesced against the affected areas. The steps to run the convert page utility will allocate the new database files, matching the file characteristics of the original areas to be converted. So again, we're talking about the number of pages and the page size. Create a new DMCL segment using the segment definitions that reflect the new characteristics, the new page, in other words, new page range of the areas that you're going to convert. Make the original areas unavailable to update through the CV or any other copy of IDMS. And of course, back up the original areas. Run the convert page using the old and new DMCLs. Again, as I mentioned, the old DMCL is specified within the sys-IDMS statement on the DMCL equals parameter, and the new DMCL is specified as part of the convert page syntax statement. After the convert page has been executed, you'll want to go through and generate and punch all of your production DMCLs to eliminate the old segment definitions and bring in the new segment definitions so that they now would have access to this new page range. As always, back up the files, making up the new database areas in case you have to do a recovery somewhere down the road. And you can make the areas available for update using the new DMCL. So this is the end of the structure of, or the discussion of using or expanding the actual database itself. What we're going to be doing, and I see we're getting kind of close to 10:50, and I've always been asked to leave 10 minutes for questions, and I think REORG may generate some additional questions. So I think we are probably at a point where it probably makes sense to terminate my portion of the presentation, and then we can continue next week on the section on modifying the database, and I can spend the next 10 minutes or so taking any questions that are available or were raised by the REORG or convert utility discussions. Len, you want to?
Yeah, great. Thanks, Dick. So if you are on the phone line, I see a few of you are on the phone, please feel free to hit #6 now to unmute your line to ask your question. And if you are in the WebEx and on the audio broadcast, please use the Q&A box right in the WebEx to ask any questions. At this point, there aren't any questions, Dick, so we'll give everyone a moment to type and or
sure.
Unmute and ask. Oh, it looks like we have a question coming in on the chat. We'll take this one, but please use the Q&A rather than the chat box. I only just happened to notice this one. Let's see. Unload, reload. I have worked one of the area. It reaches 83%. Don't have the page size to expand the area. Then I decide to unload, reload utility to perform with more primary space in the area. Blocks in the local mode files. I decide to unload, reload if there is no new page size to expand the area and it's already maximum reached page size is 32,764. Unload, reload is permanent solution to have more primary space into that impact area. We don't need to worry about area growth. Unload, reload takes minimum of at least 2 to 3 weeks of time to complete the rest of the test. Please correct me if I'm wrong.
Well, you know, was there more?
No, that's only one.
Okay. Yeah. If you're already running at 32K block size for your files, that is the maximum page size that you're going to have available. So your only option to expand the space for that would be to allocate more pages to that particular area, and then you would have to do an unload, reload to process that particular database. Now, again, on extremely large databases, it can take a fair amount of time to do an unload, reload. I don't ever recall ever seeing something that took 2 weeks, but I'm not going to say that that's not a possibility. There are a couple things that you could do. You certainly could continue using unload, reload against that area, and that easy REORG product that was created by Cogito. They're a company that was in the UK. They may have been acquired by somebody else right now, but I'm sure you could find it on the internet if you just do EZ-REORG. What that allows you to do would be to take a copy of the database and do the unload, reload against a copy of that database. And then keep the production database active within your environment against the CV so that it's generating journals. And then at the completion of the unload reload, Easy Reorg takes the journals and applies the images from the updating while the unload reload was being executed to that database. So you can bring it up to the current point in time. Your other option would be to do a reorg. And by doing the reorg, again, the Easy Reorg option is still available to you with reorg, but by running with multiple slices, you are going to reduce the elapsed time that is going to be required to do that unload reload. So let's say that it indeed takes 2 weeks to do an unload reload. If you did a reorg with slices of 2, that would bring it down to about a week to do it. If you did it, let's say slices 4, it would take you down to about 1/4 of the time, down to a couple of days. If that estimate of time is accurate. So again, the idea of the reorg is to reduce that time. But again, the reorg is going to allow you to increase the number of pages within that area, and you could reduce the page size if you wanted, and just add more pages to make up for the smaller page sizes, or you could go with the 32K. So again, you would probably just want to go through and do some of your space calculations to figure out what might work best for you. Any other questions?
I don't see any other questions out there, so I guess we can probably go ahead and wrap up. Dick, thanks very much. And for those of you who joined us, thank you as well. And as you probably already know, we're going to continue this educational series over the next several Fridays, so go out in the community to see those postings and go ahead and register, and we'll talk to you next Friday. Have a great weekend, everybody.